some of the things we do manually spend so much time and labor can actually be done for us through the application of the computer. So that we can spend more time in actually looking at because the solution process starts from problem formulation. And then you now have the solution before you come to implementation. In the pre-computer era, you can see the boxes, the solution process, because that is where you're going to do manual. So that we now have time for problem formulation and implementation. For those in electrical, okay, women of God who are having will also produce by the equipment that we said they are not there. And they are doing very well. After all, Professor is one of them. And I'm also one of them, and so many of us. I think at that point, maybe I would say I've been close or about to be close. So I have spoken as the dean of the faculty. Now I want to speak as the vice chancellor of the university. The vice chancellor from the Cincinnati and Salami would have loved here because of our busy schedule. He has directed us to the university ceremony. Brings one bit from management to the second knowledge sharing workshop. We're also very delighted that the University of Guinea has chosen to host this program. He also sent a greeting to the organizer. She is also a visitor vice chancellor. I hope you know. And she is also very happy when she, hear anything that has to do with application of computers to any process of our life. And that has also made our work very easy. If you are not aware, we have started what we call e-Senate meeting. Yes, we have a Senate meeting, and also We'll be having faculty board here on Friday. It was supposed to be today, but because of this workshop, we shifted it to Friday. And also want to strong by having a faculty board meeting. We have also, she has discovered that both costs of running the university comes from papers. And then with this agenda, bureaucracy, if you ask somebody to send a document to you through electronically in less than a minute, is there. But it's going to be done manually. Somebody will need to carry a book to sign somewhere that is received. Depending on the pressure of what they have, you may not get it all through that day. So it's very happy when we deploy computers. So on that note, I want to wish you on happy to have successful celebration, and we wish that at the end of this workshop we would have added value to our modern day. Thank you.
Thank you very much. The faculty. Thank you very much. Thank you very much for please, details the first result of the day. I want to please. I want to details the members of the team of wisdom. It's the design of micro, small, and medium enterprises in Nigeria. That is the thing. In some time, I'm told to representation. We are going to teaching our that. Making observation of the stationary vessel plan, who are going to be out in the water, oftentimes around the state of thank you. We are getting an application in the design of the micro, small, and medium enterprises in Nigeria. I will beg your next time by the institution of use of the approach. Thank you very much. It's citation of Engineer Dr. Lazarus. Engineer Dr. Asimoye is the Vice Chairman and Executive Officer of the popular Austin Labs and Company PLC. He holds a doctorate degree, honoris causa, Doctor of Engineering, 2003, from Louisville University. He holds a Master's Arts degree in International History and Diplomacy, and Bachelor of Arts in Public Administration, obtained in 2002 and 1997 respectively from the University of Benin. Also holds a Scangit certificate in refrigeration and refrigeration 1981. Started his work live in 1981 in Benin City, when he established Austin Lab Enterprises as a refrigeration and air conditioner engineering enterprise. 1982, when the company transformed to a limited company, he became a managing director and chief executive officer. Dr. Asimoye has researched extensively in the areas of refrigeration engineering, industrial policy, and foreign policy. His research in refrigeration engineering led to the invention of Austin Labs ice machine, the first made in Nigeria, ice block making machine. Please, round of applause for that. He has 3 patent rights to his patents. He has numerous national and international awards, including his National Merit Award for promoting the growth of indigenous process technology, engineering design application in Nigeria, and National Productivity Order of Merit, NPOM. Former National Vice President of the Manufacturing Association of Nigeria, MAN. Former member of the Board of Trustees of the Nigeria Cargo Defense Corps. Former member of the Governing Council, Federal Executive Leader, Niger State. Member of the Benin Forum. Member Nigerian Electricity Regulatory Commission, NEC. Member Edo State Committee on Science and Technical Education, and member Edo State Productivity Committee. Please a round of applause for these elegant scholar who's standing here before us. Is to deliver a paper on small and medium enterprises, okay. Computer-aided engineering applications in the design of equipment for micro, small, and medium enterprises, MSME in Nigeria. So, the stand on the podcast. I want to hand over the mic. I want to hand over the mic for the guest lecturer to give his.
The Vice Chancellor, Professor Mrs. Lillian Imotiyan Salami, ably represented by the Dean of the Faculty of Engineering, Professor Emmanuel Apoyi Ogujo. Right. My very good friend and brother, Reverend Professor Akin Ibadode, the former Vice Chancellor of Kupri, former Dean of the Faculty of Engineering here, all the academic giants here, the professors, and the doctors or the lecturers, the students of our great University of Benin. I said, "Oh, are you surprised at that?" Yeah, I'm still here too. Most of my degrees are here. I took advantage of living in a university city, and then joined you to pick some knowledge here too, under the tutorials of our big course there. Thank you so much. I count it a privilege to be here. I'm really humbled, standing in the midst of the teachers of teachers, the professors, the great men and women of the citadel of learning from various universities. I would have felt too small to undertake this task, that I will pick up courage to do justice for it, because I have been there in the field. You who have been here to search, and there is a great collaboration. There ought to be a great collaboration between the academia and those of us in the field, in the industry. Some years back here, precisely 2012, 2013, I had the privilege of coming here, and I think it was Professor Zemonia who organized it, where you had a program with the University of Lancaster in the UK. Yeah, one Professor Kant, hope I got the name right. Yeah, came here and made a presentation on behalf of from the academia perspective, while I presented a paper to on the fields, industrialists in the field, because their own perspective. I know the communique will reach that day for the beautiful one. And then it was that, yes, people are doing a lot here. If you open the back page here, you see lots of machines here, which are products of research, isn't it? But many of these machines are there. Many of these intellectual products of your intellectual advancement efforts are there. But what we said that time is that This effort can't really be said to have achieved its goal or purpose if it is not found on the shelves. It is not found in the shops as equipment, so that people could just go there, purchase them, and use them to make money. Where they will transform and translate into becoming products and equipment that is yielding money for both the developer. So we'll now say what should be done is that there should be the university should set up small units, marketing units, to go to those of us who are in the industry to tell us, I have this. I have this. Will you be interested? Certainly, as I stand here, my heart is open for such things because we're all differently interested in different things. I'm interested in what I can produce. I love to see it being produced. So if you get out the idea, you have done the research, and you bring it to us in Austin Lab, you will be seeing our research. But my team and myself might be seeing money. But the same profits. We see marketing and sales, see Naira and coming from it, see turnover. So not just limiting by or satisfying yourself that the main assignment today. I've been asked to speak on the topic computer-aided engineering applications in the design of equipment for micro, small and medium enterprises, MSME, in Nigeria. The microphone first to function, I can speak. Introduction. Please, what are some of the teaching aids? One is listen, taking silence, scholarly. There's a method there. Is it there? Yeah, it is there. Introduction. In today's evolving technological landscape, the success of micro. Can you project? The success of micro, small, and medium enterprises depends on the ability to innovate, I think from this. Moreover, I can't do that. In my mind, the best I can get is two more. Luckily, and there was new the Dr. Sheila. Yeah, this one is the Dr. Sheila. You could see the other. The three will call the grinder. Okay? We'll call the other one the condensing. Yeah.
And then you discover that you have to apply it step by step. From like, if you read part, you have to run down there, the other one will run down there. Now, if you take it the way it is, over from where we are talking technologies, they can't match each other. So one of the programs designing this from BIU, they have good knowledge too in AutoCAD and SolidWorks. The young man is my friend now, not like my friend. Other made first class here, and is now he has gotten his PhD. My PhD program. Now, this young man is my friend because he's very good. He did it, we were able to populate, we drove around the city, trying to say hi to, but we came back. The boy walked overnight, and when he came back, he was able to place it on simulated. Place it on top of the building, simulated building. Put this one, this is the side ridge, by the side there, yes, I don't know, the side ridge, put it here. We now discover where the things were not complex. He started working on it until we got the design right. It was an audience task communicating with the Chinese people who will make the move for us. I would say left, they will say right. I would say up, they will say down. So the only option left for me was to get our design here right. Give it to them, say, produce the move for us exactly as to what we're giving to you. If it fails, that's our cup of tea. If it works right, then people should clap for us. Eventually, with the aid of the hospital, we were able to get it right. And when the balls came, the first thing we did was to rush into production, went through the processes, we did it. I said, please, go and couple it to see whether it will match. And when they coupled it, they all matched excellently. And that took just a few days to do. Just the days. Well, I decided to use this as teaching aid to level of know as a level of education. So go back. Go to the right. Scroll up. Scroll up. Go. Yes, first here. Okay, we can start here. So now let's talk about it. Optimizing fluid dynamics with computation fluid dynamics. Those fluid fluids. This will interest you. Now, in many other countries, equipment involves fluid flow and heat transfer. I'm talking of okay, heat exchanger use the fluid to do that. Making computational fluid dynamics, the valuable CAE application, CFD simulations, help SMES techniques, optimize the equipment design by analyzing fluid behavior within the system. For instance, CFD can improve efficiency of heat exchanger, cooling system, and ventilation in industrial equipment, leading to energy savings and increased productivity. I will give you a practical explanation here. Let's take, for example, in the plastic industry. The plastic industry has to do with a lot of fluid, for the hydraulics. Now, in designing this, it become recently, some months ago, within last year, we just auctioned two very big machines, 650-ton machine, the other one 600-ton machine. Why did we auction them? We just have them because they were just there. If you put in this plastic walls to produce some of these components for you, for overnight, they might be producing 250 pieces, 300 pieces, and the operator will be clapping hands. Okay, they will be production provider will come in there and they will produce 300 pieces. And if we calculate the profit in 300 pieces, it's more than maybe 10, 20,000 naira. They can't even pay for the electricity they use for the living. Whereas the new model, which are fully computerized, that calibrated, will give you 2,000 pieces overnight. So if you have that one machine, it is better that you have 5 machines. And that can keep you on, keep you rich, keep you well, be easy to your problems, beat the level and make progress. And how did they do it? Through electronic calibration. Because those old machines were purely electrical, a little bit of electronics, but purely electrical, okay? And so they are not fully, computerized. But these ones are fully computerized. You go there. That is why mechatronics is now very much involved. I learned anybody is doing mechatronics now. Can you clap on me? Because if you specialize in mechanical, when you get to where mechanical stuff, electronic stuff, you just become like an illiterate, engineering illiterate there. So you don't know what else to do. You don't like a meeting with the spirit. Until electronic man comes, who knows how to interpret the language of the spirit? So mechatronics, you have done it, you are jamming mechanical software, robotics, and all of that in there. So all those things are now deployed in the manufacture of new machines. When it comes to where the electric motor, imagine a machine that has about, let me say now, 120 horsepower. That should be about 90 kilowatts electric motor. And then it needs to be running continuously for 1 hour, 2 hours, 3 hours. Your meter will be running like this. In one day alone, you can consume about 40,000 naira. That's what something is. So having seen this, the new manufacturers now are talking about, energy saving, and energy saving. When they calibrate, what they do is that the electric motor will only run when the hydraulic come on when you want to inject. That time I want to inject, that is the time the electronic components in it will the electric motor to come on. It will now come on, boom, then push the parallel. Yeah, immediate ignition for the electric motor. The electric motor is not allowed to run constantly continue. It comes on only during the action period. So where you are using that of electricity, so you design like so in that simulation and CAE tools that SMES to simulate and analyze complex mechanical systems such as leakages, GR, pulleys, and cams. Through mechanism simulation and analysis, SMES can verify that the equipment functions correctly, ensuring smooth operation and reducing the risk of mechanical failure during the production phase. This validation process significantly reduces the So rapid prototyping and 3D printing. The integration of scale, rapid prototyping, and 3D printing technologies empowers MOS When you study it, that sometimes here we go in. And then that was the defect to our program. It was a defect to our program. Number two was all I was saying is just to achieve this objective. If you don't, you must know the dynamic of production. If you don't know the dynamics right, you just work your capital. And this is what talking some lot of money, tens of millions, sometimes some hundreds of millions. And if you fail, they will say, that comes with borrowed money on the bank. It's not able to fix. If your business, because you don't see money, you are going to use money to pay your worker, are going to use money to pay your business, are going to use money to run over things, and to run your overhead. Yes, and all that you do in business, actually more coordinates is Myra and Couple, plus Myra. So you must be a good manager. You must be a good manager. You know, the people in the organized private sector are not like the government, like here in United, you perhaps of it. In private university, well, maybe you know, your first work, but then at the end of the month, so if you whether you like it, but it is not necessarily that I love money or people in business love money. The money you get, no, you look at if you make, let's say you make 5 million before 500,000, even 100,000 will come to you and your wife, and then you get family. It is very difficult. The money is not it's for job creation. It's for wealth creation. Now, look at it. You see the way it's working? See the design? See the design? I know this is not to you. You know, you can imagine if you, well, this became, just to the thought for me, some 2 years ago, when I was trying to design something. Now, young lady, can you go to pick up that metal design right now? Pick it up. We want to use a metal press to design something. Well, you use metal press, you press it, and then at the same time you have a cutter. That is press the mold to have the cutting edge, so that when the power press presses it, boom, the edge will cut it at the same time. They can have such stuff. So while I was explaining language barrier with the Chinese, this and that, to speak their type of English, to speak their own, that's I don't understand. You spend all make that design, put it in the cloud, put it in the
we get from the academics. Looking at the abstract. So yeah, we will see weakness there. So we have done great in terms of not really politically, but we still have some weaknesses in terms of design that is going in line for space living by analog. Looking at the abstract, the institute has been and government durable, user friendly since early 70s. Or through the see how the drone that the problem of palm oil using national techniques was improved, and it was in place that this engineering institute was brought activities have been released to settings for the year 1938. Design drawing we have made without application design. It was due to non-availability of the software as at then. This trend continued to remain slowly with software into the Nigerian market. Over 99% of the knowledge for the group at the engineering section of the institute are offered non-computer aided design as stated this by all. This is okay. That was the title. So the Nigerian Institute for Urban Research has been into engineering with technical drawings, that is the analog, one way or the other since its inception in the year 1990. It has been one of the basic components of equipment of various applications. The constitution of computer-aided design in this field progresses over the years or still a lot of attention and intervention and sustainable economic delivery on its mandate. Some of the equipment they are designed at the local Nigerian only from time to time. So here is to improve you for some equipment from the machine level and institute. First of it, production machines. This machine has been said, and it has the capacity of 1 ton power, which could be exerted to 1.5 ton power. And it can have whatever application of 50 to 100 amps. And we've been into commercial production segment since early 80s, and we've been enjoying massive patronage. The first there is called the clarifier. That is now is used to clarify both firmware as CPU to get the refined firmware or premium firmware or special firmware starting quantities, starting quantities. In the sense that FFP is less or equals to 0.5% FFP. And the debt close, you can see that then the debt content is 0, and then the water content is mainly less than 0.2%. So the next one after the first equipment that we are saying is all the diameter surface. Then the second one is called press. That is mechanical press. It employs mechanism. Now, what happened through UNDP with the assistance of the FAU, and Nigeria went into collaboration, and some foreign counterparts engineers came to the country
and they work with Nigerian counterpart engineers, and they develop the horizontal digester, which is digester, the one that is on top there. And I don't know which all we are able to the one is called press. First started with hand press, and was transferred with press. But the hydraulic press side, I don't know the hydraulic press by small Amsterdam started here in Nigeria. What happened? When it's time and it was taken abroad. Capacity of the that I get so low. So that I was saying because when we are talking technical was motivator, and based on that, at the end of the FAO program, that was early 80. So the foreign counterparts engineer had to lay. And then the Nigerian counterpart engineer then now look at the automated mean of time because of that. And from there, they came up with the idea of integrating the press to the municipal digester. And for successful, so the press was certainly supplied at the road in a small scale, and then it was not integrated with the municipal digester. And that is what involves the help of digester smoke press. So the digester smoke press, the demand is so efficient. When we talk of automated mill, what the difference between the automated mill and the digester smoke press is that that linkage is like conveyor belts and benches and used to carry product from one point to the other. That is where between what we have here and what we have in automated mill. But then we could do the conveyor belts and chains into this that to make the necessary space for our farmers. But the farmer use account about 80% away construction is something. And integrating, this conveyor system to it, make it so expensive. With about as a bed, in fact, actually due to the cost of the market, prices grow from time to time. Now, when we started the process of this equipment, it was spare 750 750 annually increasing, and currently with about say 10 million people to have this equipment. But if these linkages are being introduced, this equipment will not go for 200 million if the linkages are introduced. So what we are trying to say in essence is that we are trying to use the technology cheap enough that our local sensors and entrepreneurs be able to adopt. Then we now migrate this medium scale level and then to land scale level. Then the line here is sterilizer. The sterilizer is used to cook dyes, wet fruit using steam. The local processors and farmers, they cook the fruit inside water. It's not a loose of oil to water. So you know, and it takes a lot of time before it gets cooked. Using steam, it cooks in less than 1 hour. So it's a nice possibility like that. As a three compartments, we have the fire chamber, we have the chamber, then have the steam chamber. So the next, so you see the saliva, then the other one there is the rotary spray. So we have the rotary spray that remove the calyx from the fruit. Calyx are there from the fruit. Processing calyx with the fruit will make foam. So removing that is reduce the quantity of food that we use at one time. That is, if the calories are removed, then you are going to have exactly the weight of the food. But if the calories are not removed, then you are going to have maybe large mass of quantity, and then I will get something small at the end of the time. So that's what advantage that we use to spray. Then another machine that is very nice, the Bluetooth stripper. We decided to introduce that because we left it down, want to go into full population. We don't have plenty of people on validation and then the use of this equipment. So the market is a monitoring population. Now, when I want to bring to last year promotion, then when I automated, so this line. So these another category, the manual promotion exchange, 9 more is small scale. Say small scale, but not actually small scale. Let's say for yours to kind of differentiate the different categories which are actually for one another. So this one is but then at this point, that the head out of partition is about arms. So okay, I don't know that means multiply 150 by 50. Now give you the number of arms. Plantation. So this will have then this all meaning SSD has capacity anything less than 20. Then we develop other equipment that handle the vital loss from palm oil production. The first one is the form is the non-fiber separator. The non-fiber separator removes the knot from the fiber. Then next one, that is the 5, is the autographer separator. Then the next we have the 6, that is pound weight wicked machine. Now, the essence of this is to track the palm knot so that from there we can have the carbon share, then we have the fiber. Now, we talk of automated mill. See, automated mill feeds itself with the energy that is needed. And how is it done? It is done by the application of the share and then the fiber. And such mill, if it operates at the pressure of the timber and with its turbine, then through the combustion of the panel and the fiber, then it will be able to turn the turbine. And when the turbine is turned, then the mill can produce its own electricity. So that is used to run the mill. That is what is done with places like Okumu. So Okumu depends on part of national grid, but generates its own electricity from the process waste of the oil production. And from the process waste of oil production, we see how what's called the shell. I think that was time our prof, that has made place of a legal was a 9-4 and then was working on the combative financial to bring parts and things like that. And then from the financial, when it is warm in the vacuum, you have to produce the gas. And when that gas is condensed, that's when it's passed through water, it's condensed. And I don't have the lipid. So that lipid has a bactericidal and insecticidal ability. What does that mean? It means you can use that substance to kill glass, point of glass to dry it up, to kill it. Then I used to kill insect.
So the next, that is the 6 side, we have the briquette molding machine. It's a simple machine. It has got the principle of block molding machine. So it comes in different sizes. We have domestic sizes, and then we have industrial sizes. All we need to do is to partition it. We want to have small sizes and domestic sizes. And if we need the industrial sizes, then we go to partition. So we develop the briquette molding machine, various customers, farmers, processors, and manufacturing. And then we have the pan-waste briquette. The pan-waste briquette at the level of a small scale farmer, it can use to power their mill. So the pan-waste briquette is a combination that is with a given ratio of 1 to 3, as sort of the shell, the fiber, and then the shell, the shell, the ratio of 2, and then the fiber, the ratio of 2, the shell, the ratio of 1, then the fiber, the ratio of 2, and then the small, the ratio of 1, the small, the ratio of 1, the shell, the ratio of 2, then the fiber, the ratio of 2, 3, like that. So when it is compounded using the briquette molding machine and it is dry on a solid day for about 4 days, then can be used to power the mill. That is, start a very good market. People come and they want to place money so that it is a briquette molding machine for them, or teach them how to learn and do it. Then the always get two people want us to produce whatever they can come and buy weekly, or tell them how to go and then process it, go and do it so that they can produce it, and then part of the empowerment, then they can sell such items to those that need them. It's like then we have the other separator, that is it cracks the pan nut and then separates the shell from the nut. So the graphic efficiency is 95%, then the separation efficiency is 75%, and then the separation of kernel, that is the essence of the separator. It separates the kernels from the shell, and it is a machine system. The machine that we are taught in this case is a 8 power guys. People like European listener engine. Though it can be driven using electric motor. Why we decide to recommend this engine is that it cannot depend on the lesson. With the electric, the diesel engine can be used as it can be run in the remote area, or it's the place whereby there's the one I use electric motor for 6.5 kilowatt. But with that, I want to spend more because aside the electric motor, I want to talk of getting the panel that I want to use to control the electric motor, because of the electric motor directly in the machine. In the case of this time, can be connected directly to the equipment. So the plant mover and the machine system. How we look at molding machine, that is the 6 which I said earlier is used to mold processed waste obtained from oil palm food processing into briquettes of different sizes for domestic and industrial usage. This waste, shell and fiber, are compounded in a volumetric ratio of 1 to 3. As I said earlier, the sludge, because of motion of the smaller, the sludge acts as a binding agent that is formed there to bind the fiber and the shell together. So that is the work of that one is the ratio of 1, then the shell 2, and then the fiber, the ratio of 3, and they are moved into briquettes and dried. Then the briquette serves as an alternative source of energy to firewood. So with this, we encourage frustration, the try to discourage saturation. So next slide. So this is the application of the pan with the briquette, the mill, the bonds better and the high has a high calorific value and firewood. The only disadvantage of this is that When you put it into the fire, everything will all get hot. That can be controlled by using smaller sizes. It has less smoke, it is properly prepared and properly dried, the oil and stuff like this. So the remove of it, once very fast, and then once cleaner, then has high calorific value, and then with this, able to address problem of bring as problem in our environment. Then next one is that is plate 8 is the biggest school. So the biggest school adopts the having briquette, so the biggest school can be used to roast. Different sizes. We have they will have a twin 5 ton line. Like this is what we have seen. I think so 5 tons. Now, because oil is continue during cold weather, so what happens is that we have what's called hydrogen circulating tank, which is that first cylinder there, that one there in front of 2 horizontal tank. When water there is there, then give the cylinder, then stay here around, then makes the oil to flow, and then we use a nice place because of the steps. So the one that's most complicated is less because nice plate can still be used. So these are all of other things that have been commercialized by the institute. This one I will say is for the data who choose expansion equipment types. Just hard to choose from date fruit. You choose from date fruit can be converted into date sugar, can be converted into date jam, or like beverages and all that. So the other things are being used in the industry. It's like, okay, go back. See, the first one, that is the plate. The first one, that's the leg. That is different food statement. So what happens is that before you can be expanded from different food, that was the same. So different food is combination of sticky. That's that. When you try repeating, get big. So the statement is to break the high concentrated sugar in the date before it can be destroyed for it to be expressed. So the steamer serves. So when you put it on the steamer, the help of water is heated and then stay generated to break the saline structure of the data or choose to express. Level is used for the expression of the juice for the data food. First, then digest it, then press it out for the juice to come out. Then when the juice comes out, then it's taken into the equipment at the 12. That is a grape juice bitter press. So this one is used to remove other materials and solid form from the juice before the dispense into bottles or into medium whereby it's going to be pasteurized for you to for that usage. These are not the first one that is plate 30. It's a cloth was still liver. This one is remove the horse for putting it. And then they continue. So routine client was to try, don't meet from the oil in the express, but we will not meet. What we see in the 15 times not oil expeller. Then the next is late 16, late 17, then late 18. They are all value addition to process waste that is gotten from processing and all that. The first one that the place is footmat. This footmat can be developed for process waste of quite promotion, and then from that year. Then the other one that is the 17, that is artifacts from Gambia. From here, that is from Gambia, drums, from the leaves, then things like mat, things like wood, I produce from them, shit, car, I produce from share water equipment. The first one is that is a vertical dryer used to dry the share canal. So as the water to be expected from it. The next one is the printing, is the inside of the dryer. Down there we have this house. This house is very simple. That is charcoal in the container at the base. So it was used to heat to fry the share with the required motor content for the shell had to be expressed. Then next we have the portion miller. So this one has a two function. It crush have the share kernel, and then mill the crush material to a level that the bottom recover from it, and that is done. It's 22. It's knitting machine, but the way chocolate is being processed, oil and then it's being processed. Chocolate is being compact from the people and knitting. Manually, which is done is done by using leg. That is when the milk wants to the container or maybe in the plate, they use leg. They use leg to mash it. They could do it for 3 days for that process to be complete. And that is the because there was so much. And that led to us to do this technology with this. Within an hour, the reading process is completed. And then what happens is that when the mail goes put into the container, and there's a machine, and then there's an organ, a mixer, it will now be rotated, be it. And when what means to the line level, then shea butter will come to the surface, and then shea butter is cooked into a container, then heat or the water to escape, and then what I don't know have that will utilize the shea butter itself. The next is equipment in plate 23. That is a pyrolysis equipment. Like I said earlier, if introduce carbon shell or coconut shell into that first, the equipment by the right, sorry, the equipment by the left. When it is put into it, so back when it is into it is heated, and then some gas are produced. So gas pass through the pipe, and through that particular container that contains water to get food, and then that will make gas to cool down and convert it to liquid. And when that liquid is collected, it's called pyrolysis. So this pyrolysis is not used as herbicide or as a insecticide. Then there's the 24, that is mechanical shredder. So the mechanical shredder spread oil palm refuse sponge. That is when the fruits that we remove for the bunch. So what you have is refuse sponge. So that refuse sponge is shredded using the mechanical shredder. So shredding it, smaller particles. So the particles that are used to use the power fertilizer and used to mix with the cattle dung, food dung, poultry dyes, and used to mix with an oil meal, eggplant dyes, and form into pellets as a farm fertilizer, which is better than the chemical fertilizer that we have in the market, and it increases the pressure of the soil, increases the moisture content, so it's better than chemical fertilizer that buy from the market that crazy about. Most importantly, the global bodies and the engineering section of the institute of the section that in 1938 they are in hand where started. Which is the reason why we are here. To inherit associated transfer and visual constraints. Not need to, and what we all know, if it is a software, it can easily be transferred and it will stay a very long time. If it's not in medium, small damage, you can, without it's not damage, it will spoil a very long time. And if there is not of it, you're going to see or that of the analog. Don't say and it cannot easily be transferred and it is out of vote. So we have decided for the computer design. Non-computer design technologies are also difficult to handle as fade away with time. It is said by many that all current engineering design design and movement to attack computer design. That's what we want to do now. So what we are planning and what we want is those designs we have in the analog form. We are looking for an opportunity whereby to be converted and to be transferred. It is paramount that all engineering design information from the section of the institute is transferred into software using computer engineering design. In order to address the current challenge and endless appeal, say made towards here, those have been interested, coming to our aid, NGOs, government companies, and individual cities, so as to adopt and to also transfer the technology developed in a more productive and sustainable form. Yeah. So these are our constraints. Some of the constraints encountered in application of design here are one. We all know funding is a problem, non-availability of the computer software not there, software are not there. Don't have access to the software, even they are there. Don't have access to them, we are not even aware of those software. So we believe that this kind of forum be able to be assisted and then we get the needed software. We have some research officers there that they are willing to learn, but getting information and then the place where I will get information being one of the major constraints Gambians want to learn. The lack of facilities such as engineering, enabling environment, we have the enabling environment, the lack of awareness, we can be valuable, the computers or they are valuable somewhere for all the of it. Then locations where this software are not even education of available facilities. And then our constraint again is that our source of power is majorly for national grid. So we are looking to a situation whereby what the benefit of the national grid, the one of source is the solar energy and other sources of energy. So on behalf of the Nigerian Oil and Research, I wish to express profound gratitude to Professor A.O.A. Wadode, the chairman of the program, Professor B. Adonebe, the Night Department, the entire university community, Professor of the name, the funding organization, those that made this meeting possibility for this opportunity of expression of interest and anticipated fund intervention. Thank you.
All right, thank you very much, Dr. Reagan. Definitely, we have a new program, Agricultural Engineering. I believe the average students are here. We are going to hold on the youths. But these designs are there. People learn from them. However, the essence of this program is to use it. Thank you very much for that lecture. It's now time to move to the next speaker, Dr. Adedeji Aremo. He will be joining us virtually. I have a privilege to interact with him too during our courses every Saturday. So I want to read the citation for him here. I believe he's online. He'll be hearing us while we take his citations before we introduce him to give his own lecture. Dr. Adedeji Aremo, Coventry University, UK, he was there. Dr. Adedeji Aremo is currently a lecturer at Coventry University, where he teaches computer-aided engineering at undergraduate and postgraduate levels at the School of Mechanical Engineering. He has a decade worth of experience in designing mechanical components with computer-aided engineering techniques, with expertise in designing parts for 3D printing technologies. He graduated from Awolowo University with a bachelor's degree in metallurgical and materials engineering, after which he benefited from a Warwick University scholarship offered to 2 Africans to study for a master's degree in manufacturing systems engineering at Warwick Manufacturing Group. He was also awarded a PhD scholarship at Loughborough University, where he contributed to the development of structural optimization strategies for 3D printed parts. As a research fellow at Nottingham University, he collaborated with several industrial partners on Innovate UK projects to enhance the performance of their products with computer-aided engineering and 3D printing technology. Dr. Aremo has presented his work at plant companies and international conferences, especially the prestigious Solid Free Form Conference that holds annually at Austin, Texas, the Society of Experimental Mechanics, Costa Mesa, California, and Orlando, Florida. Dr. Aremo is hoping to exploit his skills toward improving the productivity of the sub-Saharan African region, especially affordable medical equipment, advanced agricultural machineries, and capacity development. Dr. Aremo is now with us online. We're inviting him as he delivers his lecture on computer-aided engineering of micro, small, medium-scale enterprise. Dr. Aremo, over to you, please.
Thank you very much. Can you hear me?
We can hear you faintly, please.
Okay, my understanding is that my recorded lecture was going to be played. However, I could also deliver this live if you prefer. I will go ahead to try and share my screen. Can you see my screen at all?
Okay, tell him to talk. He can talk. Talk.
Can you see my screen? Hello?
I hope he's not mute.
Hello? Hello?
Oh, he should talk. He's talking.
I'm talking. Can you see
We are
my
with you.
screen?
We are not hearing. Come in, please. We're just trying to amplify the volume.
Okay. Okay.
Loud and clear. You can go now.
Okay. Can you hear me now?
Yes.
Okay. So what I will try to do now is I will share my screen and I'll proceed with my presentation. However, the host, please can you allow me to share my screen? It says host disabled participant screen sharing. Can I share my screen now? Okay, let me try it one more time. Yes, I still cannot share it. I'm sorry. It wouldn't let me share my screen. Or should I could share the file with you so you could help me show it on the screen. I'm unable to share my screen, so you wouldn't see my slides. Hello, IT. Please, could you allow me share my screen? Okay, yes, I can now. Thank you. So I will share my screen and I will proceed with my presentation. Can we all see my screen now?
Yes.
Okay. So hello everyone. My name is Deji Aremu, and I am truly grateful for the opportunity. I'm truly grateful for the opportunity to be speaking with you today with my area of teaching and research. I am a lecturer at the Coventry University, UK, and also a fellow of the Educational Academy here in the UK. I am on a project collaborating with several universities in Nigeria, University of Abuja, University of Benin, Ahmadu Bello, Abubakar Tafawa Balewa University, sorry about that, Federal University of Technology, Minna, Mustard Seed, and Laxonic Engineering. So we're on this Royal of Academy project, which is funded by the UK government. And the whole idea is to see how can we use computer-aided engineering to advance mechanical engineering and manufacturing in Nigeria, particularly. So today I'll be speaking with you on computer-aided engineering for micro, small, and medium enterprise in Nigeria. So who am I? I will talk a little bit about myself, what I've done before, and then go on to talk about my understanding of what micro, small, medium enterprise are. Before I then try to explain to you what CAE is, and then that would set the stage for for when we talk about how can CAE help these companies. I will talk about these companies in UK, US, Canada, and Germany, then talk very briefly about CAE software. I'll conclude my talk today by telling you about the Nigeria's manufacturing deficit, which is a little bit quite serious. Now, my name is Deji Aremu, like I told you, and I began my career as a metallurgical and materials engineering student at Obafemi Awolowo University, where I was involved in developing some finite element code to predict the fatigue behavior of a notch specimen in AutoCAD. I then went on via a scholarship to do a master's in manufacturing systems engineering at Warwick University in the UK. After then, I went to Bristol to do on a project to use finite element analysis to improve the properties of what we call auxetic materials. These are quite strange materials with negative Poisson ratio, and they have very good impact absorbing qualities. After then, I was able to get a scholarship where I went to Loughborough University, again in the UK, to do a PhD in designing for 3D printing with CAE technology. I later went on to Birmingham University, collaborating with Rolls-Royce to use CAE to model the investment casting process so that we could anticipate flaws in turbine blades, which are used for aircraft engine. Then I didn't talk about my Nottingham experience. After my PhD, I spent 7 years in Nottingham as a postdoctoral research fellow at one of the top 3D printing research groups in the world, where we were using CAE techniques to sort of exploit capabilities in 3D printing and additive manufacturing technologies. After my work at Birmingham, I got this position in Coventry where I am, where I currently teach several undergraduate and postgraduate students, CAE, and I supervise a lot of projects collaborating with companies, all of which use CAE for product development. So Coventry is actually quite a top university when it comes to teaching and research. It's one of the best teaching university in the globe, and it's also in the what we call the West Midlands, which is the home for headquarters for Range Rover. There, obviously, I'm sure you know about this car. So what that allows is that we do a lot of research. We do a lot of research for a lot of automotive companies, and also we do aerospace research. To the plane you are seeing there, that is actually our laboratory at the university, where we teach aerospace students on about the components of an aircraft. Now, that plane you're seeing there was used during the Second World War. So it has since been retired. It's now in the laboratory for teaching and research. Now, who are MSMEs? It is very important we understand this because it will help us understand what it is we are trying to do. From my understanding, MSMEs are the backbone of many economies. MSMEs employ many unskilled and semi-skilled laborers. MSMEs contribute to exports and GDP of any nations in the world. And they supply raw materials, products, finished parts to the bigger companies. So in US, you might have probably a company like Boeing that makes aircraft. But all the minute parts that goes on the aircraft will be made by MSMEs, right? And they will support the operations of Boeing, right? In the US, there are about 30 million MSMEs. In the UK, that's 5.5 million. And Australia claims to have 98% of its companies are MSMEs. And these are just little companies making small things to support the bigger ones. In Canada, that is 1.9 million, and Germany can boast MSMEs value of about 2.6 million. Now, these are significant numbers. So in 2005, the European Union tried to classify these companies in the separate groups. So when we say micro enterprise, which is what the M stands for on top there, we mean enterprise where the number of people are less than 10. Employees are less than 10. And their annual turnover is just about 2 million euros. Sorry, I'm using euros. I'm currently in UK, so that's why. And small enterprise have its employees 50 or below, and its turnover is just about 10 million euros. While medium enterprise, the number of employees can increase to 250, and the turnover is just about 50 millions. Now, so how can CAE really help these companies? We've established the fact now that these companies are the backbone of the economy. So if you help them, what it means is the economy can grow. Now, what really happens is that Africa, sub-Saharan Africa particularly, I was quite impressed to hear what one of the professors was saying there about what he has done on CAE. That's actually the first company I'm hearing that has used CAE extensively. And I was really, really happy about what I heard there. But its case is quite unique. We have not really exploited CAE to the fullest. And so there's a huge opportunity. If you are aware, recently, several nations in Africa came together to form what we now call the Africa Free Trade Area. Now, there's a danger with that kind of market we just created. It might be a useless market if there's not enough goods to go around, right? So I'm not necessarily going to buy a Ghanaian car or a Congo motorcycle because it's from Congo or Ghana. I will buy it because it outperforms maybe my Toyota or any car that I'm buying from outside the African Free Trade Area. And what you have to realize is that a lot of companies on the global scale use CAE to improve the quality of their products even before it's made. So you simulate the performance, you know how it will behave on your computer. Then after you're sure, then you make it and test it and find out if what you see on the computer agrees with what you see experimentally. That is the only way you can compete in the market. And a lot of companies are using CAE now. So African products, Nigerian products will never compete now on a global scale if it doesn't use some of these sort of capabilities to improve the performance, right? And we have to realize that at the root of our problems in economic development is the fact that we are not making the world what the world needs. If we make things that other people in the world need, then what that means is that foreign direct investment will pour into our country. And we can achieve this for our MSMEs with CAE. Now, what is CAE? CAE stands for Computer Aided Engineering. Let me clarify one fact, and I always say this. CAE is not computer aided design. There seems to be a misunderstanding that it is computer aided design. It is lots more steps beyond computer aided design. I was really very happy when I heard the professor say the same thing earlier today. It shows that at least some understanding is there, but this understanding is not well understood in a lot of our manufacturing industry. So what you're doing when you're doing CAE is you create the CAD file for the design, then you impose on that CAD file the boundary conditions, the things which the design is going to experience in service. That way you can predict how it will perform. You know if your product will fail or if it will survive. And obviously, a lot of us might know what computer-aided manufacturing is. But again, I'll reiterate that CAE is not computer-aided design. It's much, much, much more than that. Now, we start from engineering. We start in engineering. At least I learned in IFE that you can draw orthographic projections of a design, an engineering drawing, like I'm showing there. And the world has now advanced now and started making 3D models, as you can see on the right-hand side. So what really happens, you see these orthographic projections, these 2D drawings, but they found that it has a lot of limitation. It can't express some design details. This necessitated the need for 3D models. Now they've now gone on to say, okay, now we can make 3D models. We can draw 3D models, I mean. How can we find out how it's performing before we put 10 billion pounds into mass producing it? And this is what CAE really offers for you. Now, for you to understand CAE, you have to know what a model is. Whenever we're doing CAE, all we are doing is we are creating a model of what is happening physically. So you can model the process. You can model also the parts. Now, this slide is just to show you an analogy. Normally, when you think about it, we have so many models around us. We have sculptures, we have toys, we have fashion models, we have computer models, we have architectural models, we have role models, mathematical models. What you see is that all these models, right? All these models, they are not exactly a replica of what they are trying to model. They only capture the essential features necessary to an objective. So on a CAE project, the customer might tell us, oh, could you help me improve the performance of this part using CAE? Then when we ask them, what do you mean by performance? Some customers might say the displacement must be lower, the stresses must be lower. And we go ahead and just create a model that models that. Some of them might be interested in structural rather than thermal properties. Again, the model focuses on that. It is very important you know that you're not modeling a direct replica of what's going on, but what is relevant to the objective of the project. In physics and in engineering, a lot of geniuses and wise men, they've done a lot of work for us. And what they've done is they've created mathematical models to replicate, let's say, things like motion. We've got Newton's laws of motion. You have to understand that these laws are approximation of what is going on. And we also have the Hooke's law, which is what I deal with a lot. And Hooke's law tries to predict to you the extension a spring will experience if there's a force on it. That is if you know the stiffness, right? So that is what the Hooke's law says. They are mathematical models. But the question you ask now, I'll skip this slide now. This question you ask now, how do all these formulas in which we are taught in our universities, how do they translate to things that are much complicated? This is a huge problem. So what I'm showing you here is an engine block, and how can you find out the displacement and stresses in the engine block due to the movement of the pistons or something? And if you can do that, then you can design it better and it wouldn't fail and cause an accident, right? This is where CAE steps in, right? This is where CAE steps in. What I'm showing down here is a complicated dynamic system, right? Very, very complicated. You can use hand calculations to know the acceleration of A and B using dynamics. But when it comes to a complicated dynamic system, you need something much more complex. So CAE is used, is basically you're using computers to predict the performance of complicated products, right? And it's the reason why we have CAE today is because our computers became better over the years. Because what usually happens in CAE is you have complex arrays, matrices, and things, and these are solved to give you the performance of that product. Whenever you're doing any CAE technique, the most common one, know that there are 3 stages. The first one is what we call pre-processing. This is where you create the card, right? This is where you get the material properties, right? Be it linear or non-linear. And then you look at what loads and boundary conditions that part will be experiencing. I'm sitting on a chair now, and I know that the legs of the chair are restricted from moving downwards, and my weight is acting on it. Therefore, I'm inducing some sort of stress in there. So all this information you collect, then the next stage is to solve. And this is basically using numerical methods, most of which you've been taught at your universities, to solve the equations that you form at the pre-processing stage. And post-processing is what do you make of the result? How do you view it? What do they mean for performance? So this is how we do CAE, and you have to keep that in mind. Now, my experience is this. When someone tells me a lot of our universities in Nigeria are backward, I don't quite agree with them. What I think we need is that small knowledge, like this presentation I'm giving you, to see how a lot of what you are taught is relevant to actual products. And when we get it, you see that most of what we were taught in undergrad in Nigerian universities are actually world-class, I tell you. Keep that in mind. So there are so many CAE techniques now, and a lot of them are still coming up. The most common one and most established are finite element analysis, computational fluid dynamics, multi-body dynamics, and optimization. It is very difficult for you to get an expert that knows everything, right? So I have worked a lot in finite element and optimization. I've also done some work in computational fluid dynamics, but it's not easy to get an expert in everything. You might get someone that knows slight of all, but not an expert in everything. So I'm just showing that those are the areas I've worked. So let's go back to MSMEs now. Now, when it comes to the MSMEs, this presentation refers to those that are engineering, right? Those that are engineering. So engineering MSMEs, they face a dire global and local competition. If we want to be exporting finished goods to the continents, to the planet, we need to begin to use tools that will allow us compete without spending excessive money on testing. We don't even have the money to test in the first place. We don't have expensive and sophisticated testing labs like they have in the developed world. So we can as well use the cheaper option, which is CAE. Now, to maintain a good share of the market, MSMEs must be agile. You have to be agile. So what I mean by that is the customer needs is changing. Customized goods now is the order of the day. So we need things like CAE in all these MSMEs to make our companies more robust for the challenges of the 21st century. Now, CAE, I was googling this some days ago, and I found out that CAE global market is valued at $7.23 billion and is expected to grow to $17.68 billion by 2030. I'm afraid that Sub-Saharan Africa has not exploited this a lot. And some of this growth, if we don't do something about it, will not happen in Sub-Saharan Africa. And if that happens, what it means is that we'll still be importing spare parts for all our automobiles from abroad. We'll be importing every tiny thing when we can make them and make sure they are performing exactly the same as those abroad. The dangers about even importing so many material abroad is that there's what we call metrology. And I was explaining this to our students some days ago, is that if you take a measurement of a ruler, if you use a ruler and use it to take a measurement of a rod in the UK, and you now bring the same ruler and rod into Nigeria, and you take the same measurement, you'll be measuring two different things, because the thermal conditions and the environmental conditions in Nigeria might have caused the ruler and rod to extend in a different way, but you will still measure it and say it's the same thing. So what does that tell you? That tells you a lot of the imported products we are importing cannot perform the same way they do in all these advanced nature countries. That means we need to develop our own, and CAE can strongly help us with that. So finite element analysis, which is one of the most established CAE techniques, can help you increase the accuracy of your design. It can enhance design, and it can give you more insight into what parameters in a design are critical. It can allow you do rapid prototyping, and it will make the design cycle more efficient, right? And increase your productivity. This is absolutely essential. Now, all over the globe, there are several industries now using CAE. Manufacturing is using it. In terms of manufacturing, a lot of there's a tendency, if you're doing manufacturing, if a part fails, you replace it with a new part. You don't consider that, oh, can I increase the design to help it? Aerospace is using it. Civil engineering is using it. Transport is using it. Defense, oil and gas, nuclear, wind, processing, medical device. In terms of medical device, I'm a little bit passionate about this because in Nigeria, our healthcare is not what it ought to be because of expensive equipment. And you can use CAE to design things. When you couple that with 3D printing, that's massive. During the COVID era, 3D printing was used a lot to make cheap respirators. Keep that in mind. And you can design these things with CAE, and even domestic appliances at home. Everything can be designed with CAE. Now, I'm going to end my presentation with a case study. Let us consider this company. I googled online to find out this company, GS Products. They make all sorts of devices. One of their products is a hook, and they make all sorts of hook. Now, for them to be able to adapt each hook to a particular application, they could design this with CAE. Like those hooks which is shown on this slide in the lower part can handle much more weight than the ones on top. But the problem is, if you use the ones below for applications above, you will be wasting, you might waste a lot of energy because this might be heavier, right? So CAE can actually help you know exactly the amount of material you need to fulfill a criteria, right? So it's not just about just designing one thing, you have to design it efficiently. So a lot of automotive companies all over the world now, they use CAE to reduce weight. Now, and what can you use the hook for? You can use the hook in an agricultural equipment. Now I'm using the hook as an example because it's a very simple device, right? Which I'm hoping you get to understand. If you see this conveyor system here, you can see the hook is up and you can attach it to a tractor. And when the tractor is dragging this, you would not want it to fail, right? Again, you can know how to perform using CAE. Obviously, you can use the hook also to lift heavy crane. Again, you can design appropriately. And you can use the hook to tow a vehicle from one part to another. Again, the kind of hook, the material properties you use will vary with the application, and CAE can tell you all sort of this. Now, for critical application, just imagine that the military has said, as a Nigerian company, okay, let's dream a little bit. The US military has said, as a Nigerian company, we'd like to buy your hooks, right? We want to buy 10,000 hooks, right, for the military. Now, they want to use it for this kind of application for a rescue mission where they use the hook on here, and the hook is meant to carry this sort of thing. Now, you wouldn't want a case in which when the helicopter is saving maybe the military personnel, the hook fails, right? The hook fails. And then also the sort of hook you will need to carry a vehicle will be very different from just to rescue one person. And you want the hook to be performed at utmost performance when this happens. So again, CAE is being used by a lot of all these militaries abroad to determine performance before they invest billions and billions of dollars into this equipment. So I'm showing you here the kind of results you get when you do CAE. So if you do a finite element analysis on these hooks, right, you will get this sort of image we're showing here. And basically this is what it's saying. It's showing this is a stress distribution, stress analysis. So what it's saying is this color is saying that the blue region are the region where there's low stresses, and the red region are the region where there's high stresses, right? You can then check the stress and see, is it above the yield? If it's above the yield, you know the product will fail, right? Because you don't want it to get to the yield. So this is the sort of things you do. When you do CAE, ideally, normally it's numbers you get in different part of the structure, but you use a color scale to know, to plot the numbers, assign the numbers so you can interpret that. Now, a hook is not the only product you can design. You can design an engine block. You can design a piston, a gear. On our Royal Academy of Engineering project, we are teaching students how to analyze a bicycle using CAE. They can design a bicycle. I was telling one of them, I said, I'm longing to see a company in Nigeria that makes bamboo bikes. If you Google on the internet, you see bamboo bikes, and people are using CAE to see how you can use bamboo sticks to make bicycles rather than metal. This is for sustainability, to meet the Sustainable Development Goals. If you can do that on a mass scale, what that means is we can cheapen the cost of bicycle and improve mobility in our villages. Already there are bikes like that, but we can improve the performance. Now, also in biomedical, CAE is used to elucidate some sort of injury that might have happened to a person, be the skull and everything. And finally, CAE is used to design prosthetics. Prosthetics are basically just devices that are used to restore a lost limb so that someone that has lost a loved limb can get up again. So this is the, I think is a femur, the upper femur, and then this is a prosthetic device to help the person. Now, yesterday, 2 days ago, I just walked around Coventry University and said, you know what, let me take some images and talk some products you could design. Now, the first thing which you could design, even with CAE, commanding items, is this is a bicycle shed. We could use CAE to find out if this bicycle shed will stand, given the support that is given to it. I'm pretty sure this is what they did to come up with this design. Also, you could include the wind loads to find out in the case of a heavy wind, would this structure survive? Also, there's this very tiny part at the back of this fire extinguisher holding it. It's very small, but it's able to hold the weight of that. Again, these sort of things for a small company designing these tiny things, CAE can actually help them design something that can stand the set of time as the span of time anyway. Now, with this is a monitor. I'm sure you all know there's a cantilever beam here holding the weight of that. Again, you can do some CAE to find out if this stand will stand. And also this chair just having a leg down, and then you can use CAE to come up with designs that are really innovative, which you would not have thought of before. Now, when you're doing linear CAE, you probably will need Young's modulus, Poisson ratio, and yield stress. However, please note that CAE is more than finite element analysis. It has optimization algorithms, which is very broad. But we usually teach CAE starting with finite element and analysis. Now, there is a broad range of softwares that you could use for CAE. So many of them. I'm only putting a few here, so please don't assume that I have everything here. Now, some of them are commercial, some of them are free. But the issue is this: a lot of this commercial software, that is, if you're using the real one, not the fake one, they will charge you a license to use to develop your product. So the problem is this, and some of them can cost as much as £10,000 for one computer for 1 year. But what I found out is that we don't have any commercial software that has been developed by an African, a sub-Saharan African country. If we had, we can reduce the cost and begin to offer our manufacturing and also our mechanical companies analysis capabilities for them to design a broad range of products. How many companies in Nigeria will be able to afford £10,000 for one laptop in 1 year? Now, this is a very a setback. This is why I keep saying this, and I tell my students that we need to develop our own software so that we can even use this software to earn income when we sell the licenses. And we already have everything we need. We have the numerical methods. We understand all the numerical methods. It's just for us to form a team and do this. Now, finally, I would like to say, I hope I haven't exceeded my time. I would like to say that the Guardian, the Nigerian Guardian, says there are 39 million MSMEs registered in Nigeria, which contribute 46% to our GDP. Now, a part of that, there's going to be a lot of engineering companies there, right? Just imagine if they can begin to use CAE in a very constructive and very innovative way. We can boost our GDP in all sorts of ways. However, there's a serious deficit in our curriculum, which doesn't teach CAE effectively to the students. Again, I'll reiterate that CAD is not CAE. CAD is just the beginning of CAE, just like a professor said. CAD is the beginning of CAE. So we now need CAE consultancies to rise up, going up to the company and say, you know what, I can offer you this capability to analyze this part, and I'm sure I can improve your performance by that. So we need that. We don't have enough, right? At this point, I would like to stop now. Thank you very much. If you wish to speak to me, you can contact me there, or any member of the team. You can speak to them, and we will be ready and happy to help you. Thank you. Any questions? Questions? Any questions? Are you still with me? Okay, I'm not sure if you're there. Hello?
Hi, I'm with you, sir.
Okay, yes. So any questions? Or that's the end of my presentation.
No, sir, I joined late, so I don't have any question.
Oh, I'm even talking about the live session there. It looks as though I might have lost connection with them.
No, my own connection is okay. I'm seeing everything I do.
Yes, okay. Hello, Uniben. I've finished my presentation now. I think I have to contact them. Hello, sir. Okay.
You result your friend using crack versions. You know, the question I'm asking, I just have to ask the brother. I thought, what I don't want to find out is when they use about there, you pay. I know you just have to pay to keep the software running, you must renew. Here in Africa, because of plenty of funds, we oftentimes to pay for this software becomes a problem for us, so we oftentimes use crack versions. What I want to find out is the results that we normally obtain using crack versions. And then the same with the ones that you put use over there. Government times that's what we parade here. So I just want to find out that difference. And again, people like you that have been there, in what way can we get software that are not cracked that different institutions can actually use for engineering training, for to be aided in the design and all. Thank you.
Hello, can you hear me? Yes, sir.
Hello?
Hello, sir.
Yeah. Did you get this question?
I didn't hear his question properly, sir.
What his question is all about is, can you use the card version with the one you normally use in the UK?
Does it mean the computer aided software?
Yeah, like the computer aided software, we have the crack one here.
Yes.
So what he's trying to ask is that the results you get from the crack one, is it the same with the ones that you use if you're using the new one, the licensed one?
Okay. I will try to answer that. Indeed, there might not be too many difference. I don't think there's more difference, but you have to be careful. If you want your product to be sold internationally, and it becomes evident that the crack ones was used, you could be sued. You could be sued by the software companies. Again, you might get away with it, but honestly, I'll say be very careful, because a lot of work and a lot of brain has gone into developing this software. So I think we should strive to develop our own, and we have the capability to do it, right? So indeed, maybe you might want to use the cracked one and use it and not tell anybody that that's what you used. That's up to you, but be very careful about that one. If they can prove that you use the cracked one, it's going to be a legal case, and they could claim millions of pounds. I don't know if you heard my answer. Yes. So if you are a company that is hoping to go to expand your product across the world, just be very, very careful. That's all I'll say. But again, what I'm encouraging is that we develop our own capacity.
Okay. But what now happens now is that you can't publish those ones that are cracked in highly reputable journals, because once they see your results, they want to have the license number and everything that pertains to the software that you use. And that means you can only publish locally. Yeah.
Thank you, sir.
So we appreciate that. Those of us who are already in the training program, what Dr. Deja just done is support. So please, the volume or the audio sound was very poor because of the stoppings so quickly. But I believe all of us have learned from that presentation of Dr. Deja. So please, if you are in, keep in this Saturday so that the training can continue. Because of time, the two last speakers, we're going to move them to the program tomorrow morning because of time. And at this point, I will be calling on Professor Ishmael Dagwa, team leader, to talk to us.
Thank you very much, Mr. MC. Good afternoon, everyone. I'm not going to deliver another talk, but mine is a very simple job. Is to deliver the board of time. I think the microphone is audible enough. Yes. Just a little background, because it is very important for us to know something about this project. This project, before I continue, please, kindly allow me to stand on the existing protocol because I will give the board of time. This project is funded by the Royal Academy of Engineering, which is based in the United Kingdom, under their scheme called HEPSA, Higher Education Partnership in Sub-Saharan Africa. The purpose of this is to ensure that higher education in Sub-Saharan Africa produces engineers with the skills and knowledge required to meet the needs of the industry, tackle local challenges, address the engineering skills shortage in Sub-Saharan Africa, and to showcase engineers' role in driving sustainable and inclusive development in the region. This project, as earlier mentioned by the chairman, is structured in hub and spokes manner. The hub is University of Abuja. The spokes university include Abuja University in the Bauchi State. We have Federal University of Technology, MENA, is in Niger State. We also have Great University of Benin, University of Benin, our host for this second sharing workshop. We also have industrial partners. One is Laxonic Engineering Services, based in Port Harcourt, River State. And we also have Mustard Seed High Tech International Limited in Norman. They used to have this program, who was in the area. But that's where is Norman, which state? Maybe so many. Norman is based in Adamawa State. That is the structure of this project team formation. Going to the vote of thanks now. Anytime I come to you, it's homecoming for me. I'm privileged this afternoon to have the chairman, who is my mentor, not only mentor to so many of us. He has grandchildren too that are mentored by those mentors. It's a very wonderful privilege. We want to, first of all, thank the Vice Chancellor of the University, Professor Mrs. Vivian I. Salami, ably represented by the Dean of Engineering, Engineer Professor Emmanuel. We recall that the Dean was here in person, but for some other official engagement, we have to leave. So please, we appreciate the Vice Chancellor for the support given to this project. Right? We want to also thank the chairman of this occasion, Professor AOA Ipadane, the former Vice Chancellor of the Federal University of Petroleum Resources, April in the state. He has been with us. He was the guest speaker at our first knowledge sharing workshop, which was held at the University of Abuja. And he's also here today as the chairman of the workshop. We want to appreciate you and thank you very much, sir, for your persistent support in this project. We want to very much thank our special guest speaker, Dr. Austin Lazarus Asimoye, Chief Executive Officer. We want to thank you very much for that wonderful presentation. Our students that are in our midst will appreciate the need to link this theory and what is happening in the field. Outside there, the society is looking forward to what we can deliver after our programs. I remember I was once asked one of the companies, very simple question, but it means a lot. What can you do for us? Always ask yourself this question, and you will remain focused. Thank you very much, sir, Dr. Lazarus. We want to also thank the team in his own capacity as the dean of the Faculty of Engineering. We heard when he met that they have to shift and propose that's supposed to have been held here at the podium to Friday. We want to thank you for being there for us and for the support and sacrifice you are given to this project. Thank you very much. We want to also thank the funders of this program or project, the Royal Academy of Engineering in India. It has been wonderful providing the necessary funds to enable us to execute this project. Thank you very much. We want to thank all the speakers that were invited for honoring our invitation and sharing with us from your wealth of experience, your knowledge. We appreciate all your input. We appreciate your deliveries. We have our lift out again for special recognition. Dr. Austin Lazarus, Professor A.O.A. Ipadane, Engineer Dr. Sunday Vegan, Director of the night. Thank you very much. We want to thank Dr. Adedeji as a new government We have government university in Nigeria, but they are the government rules. The other speakers will deliver their own, we share the experience with us tomorrow because of what we plan. We want to also, in a very special way, appreciate all professors that are here, heads of departments and lecturers. Thank you very much for honoring me. We want to appreciate and thank the members of this project team. I want to please request them to start off for recognition. As I mentioned, they have been doing great job. We've been working together in unity, and we've actually had very good outcomes. In no particular order, may I invite Professor Patrick Amirahi. Thank you very much. Trusted us, and you know it's not easy to plan a program like this. We want to say thank you, extend our appreciation to your team. We appreciate you very well. Thank you. Please, you can have your seat. We also have Professor Tokan of the Abedekar University, Bauchi, all the way from Bauchi State. Yes, we thank you very much for the commitment and the support. Next, we have Professor Olukobi Oluwafemi Ayodele from Federal University of Technology in Manhattan. Thank you for the major support. We also have Engineer Chief, the CEO of Electronic Engineering Services. So, thank you very much beyond the support and the cooperation. We have as our speaker, Dr. Adele, one of the speakers. Thank you very much for all of you there. They have been doing great job every Saturday, except the kind of shift because of under engagement. They have been training us on the use of happiness and computer aided engineering. Thank you very much for all the sacrifices and the commitments. We appreciate it. We also have Mr. Nathan Williams of the Northwestern Hybrid International Limited Company. And then I want to thank you for the great work you are also doing. I was just mentioning this in the report earlier on. I mentioned to have grandchildren too, speaking to our mentor, Professor Ibadene. The CEO is my former student. Okay. So you can see that. Thank you very much. Yes, you can have your seat. I want to also say that the team lead, Professor Misha and Mr. Gabon, from the University of Education. I want very much, in a very special way, appreciate and thank all our students and staff. Students were very faithful to meet with. Yeah, because there is time for everything. So we are seated here at the front, of course, elders are here, and we understand that those who are at the back, we are critics. Because the success of this project, and those are mentioned by the special guest speaker, the success of this project depends on you and your success in the success of Nigeria. So please, I know how I make effort to convince my friends. I said, please, this project is very important. It's timely. Well, of course, you know the response. For some, they will show commitment, others will give this security. Please, I want you to really take this project very seriously because it is free. If you were to enroll into similar projects or schools, you know how much they pay? It's a lot of money. Here we just started the training. We've done 14 weeks now, and we intend to give 45 weeks. So if you are yet to start, it's not there for you to take your interest and participate. It is done every Saturday, 11 a.m. to 1 p.m. It's worth it. Please sacrifice your time. As Area mentioned, the issue of craft version and so on. For this project, we've been privileged to have licensed version being used, that's the student's version from Altea. We're using here. I mean, we were using Hypermesh. It's Hypermesh we are using. So we are free, we can use it very well and acknowledge them that they assisted us. It's not class version. For those in this particular project, have that assurance. We want to appreciate and thank all the guests that have honored this invitation. Some came and they left one engagement or the other. We want to thank you very much. We want to thank the members of the press, the information unit. Thank you for the great job you are doing. We want to appreciate each and every one here that I might not have mentioned by the way of listening on this stage. Please, we acknowledge you and we appreciate your support and your sacrifice. By the grace of God, tomorrow we intend to continue. That's the second day now. And you will have more time to ask your questions. Our focus is we want to see how we can modify the mechanical engineering design curriculum. Having had the expectations from the industry as well as from the classroom, any idea that crosses your mind on how best we can really teach these courses in our institutions of learning, please feel free to share with us tomorrow. Great time because it's worth it. This will serve like the roadmap. Once we get the design right, by the grace of God, we will get to product, heavy institution, and economy. So please come with great expectations tomorrow. We still have some experience to be shared by some of the and members of the team. On this note, I want to say thank you to the MC. Each and every person, thank you very much. On behalf of the project, God bless you. Thank you very much.
Thank you very much for that vote of thanks. We have now come to the conclusion of this phase program. Hopefully by 8 now, it's permitted to have a look at the program tomorrow. At 8:30 to 9:30 a.m. tomorrow morning, registration of guests will commence. So students, please, we want to beg you still. You can sacrifice that time for us and attend. Though we know you clash with your practice, but it's worth it. So we are all invited. At this point, we want to bring the session to a close. Having instructed and mandated by Professor Patrick Amiolebe, so call on engineer Mrs. Ijoma Inobe to conclude with the closing prayer. So please, if we're able, stand up to does that.
In Jesus' name, Father Lord, thank you. Father Lord, we give you all the glory, all the adoration, be unto you, Jesus' name. Father Lord, I want to thank you for this great lecture, really giving to us. Father Lord, bless our people who are given us this privilege to be here, to hear this seminar. Father Lord, I thank you for the chairman and the special guests, national and local. Father Lord, give you all the glory. Father Lord, bless them. Give them all the heart's desires. For them to come here today to grant us this free lecture. And Father Lord, give them good health. We take their health in Jesus' name. Madam, as we are here today, this lecture will not be lost for us. We are also gain from it. We as lecturers here gathering here today are also going to impart on our students. These are many blessings we pass through us and our Lord.
Okay, please, group photograph, please. Group photograph. On the standards, please. Group photograph. Group photograph. Group photograph, please.